Okay, this is week 5, protocols and addressing on networks for the CIS 1103. Why we need networks? The network will provide you with a method to communicate and share information. So all communications, they begin with a message or information that must be sent from one end, from the transmitter to the receiver, or from the sender to the receiver. So all communication methods, they have 3 elements in common. First is the source or the sender, the destination, and the medium: cable, wireless, fiber, channel. Okay. But before the sender and receiver, they start communicating the data, they must agree on the protocol, which language they will talk. Are we going to use IP protocol or other protocol? Okay, or TCP IP or other protocol. So what the protocol will decide what method of communication should we use, what language should we use, do we need to confirm that our messages are received. So these rules, we call them protocols, must be followed for the message to be successfully delivered and understood. And everything has protocol. When you talk to your friend, it's different than when you talk to another stranger, or when you talk to your teacher, or your parent. So everything has a protocol. So an identified sender and receiver, this is the protocol rules. Agreed upon method of communicating, speed and timing of delivery, confirmation or acknowledgement requirement. Does the receiver, when receives a packet, needs to confirm that, oh, okay, I received a packet, or no confirmation, no acknowledgement is there? The protocol characteristics. We have the message format. When a message is sent, it must use a specific format or structure. The size, it depends on the protocol you are using. The timing, it determines the speed at which the bits are transmitted. Encoding, what encoding is used when the message is sent across the network. First of all, the message is always, everything in the computer is converted to bits, zeros and ones, bits. Okay? By the sending host. Each bit is encoded into a pattern of sound, or maybe light wave, or electrical impulse, depending on your media. Okay. The destination host receives and decodes. It will convert it back into bits. The encapsulation, which encapsulation is used? Each message transmitted on a network must include a header that contains addressing information that identifies the source and destination hosts. Some messages requires an acknowledgement before the next message can be sent. If it's reliable, it will have acknowledgements.
It's not necessary.
Yeah, if it is a reliable protocol. Yes, you are right. Like UDP does not provide acknowledgement. TCP provides that. So what is a standard? Standard is a set of rules that determines how something must be done. The networking and internet standards ensures that all devices connecting to the network implement the same set of rules or protocols in the same manner. Using standards, it is possible for different types of devices to send information to each other over the internet, because they already agree on the standards and protocols. The two models that are very popular and dominating are the TCP/IP and the OSI model. OSI Reference Model, Open System Interconnection Reference Model, OSI, helps network engineers, network administrators, system engineers, and manufacturers to define how data communication occur on a computer networks from one computer to another, regardless of where the computer is or what software it runs. So the general rules. It is composed of 7 layers. Okay. Each layer communicates to the layers adjacent to it and its equivalent layer on the receiving device. That's why we call it peer-to-peer. It was created by International Organization for Standardization, ISO. That's why the name was the opposite, OSI. It was created by ISO. And is represented in the United States by the American National Standards Institute, ANSI. This is the 7 layers of the OSI. Okay. We start from 7 to 1. We go down to 1. As you can see here, the application layer communicates with the application layer. It's a peer-to-peer layers. Yeah, here we have, this is the transmitter, the sender. It has 7 layers. And this is the receiver. It has 7 layers. So the application layer will send the packet or will send the data. It will go down from layer 7 to layer 1, then to the receiver 1 until it reaches 7. If it is going from TCP here, transport layer, it will go down here, and then it reaches here, and then it will go to the transport. Peer-to-peer. Okay. The encapsulation, in each layer, it will do encapsulation for the data. And we give it a name. Like now, the encapsulation naming. And now we are all human beings. When you are in the college, you are a student. When you are working, inshallah, after you graduate, or maybe you are graduating and working, you are called an employee. The same thing. When the data is in each layer, it has a name, according to the function of the layer. The data in the application, it is data. Presentation, session, data. In the transport layer, it's called segment. These are always coming, these questions. What is the data PDU name in the transport layer? It is segment. In the network layer, it is called packet. Packet. In the data link layer, it is framed. In the physical layer, it is bits. By the way, here you see in segment and packet, we have header only. In the frame, we have header and trailer. See the difference? In the frame, we have header and trailer. In packet and segment, and in the session layer, we have header. Only data link has header and trailer. The encapsulation, when it arrives, it goes the opposite way. So it will arrive as bit, and then as frame, then as packet, segment, and then goes back data to the application. Understood? Is it clear? So here we have different users. Let's start with the application layer. What does it do? Application layer, let's try to understand it by giving example of protocols used in the layer, in the application layer. For example, if you are using your browser, the internet, you are using the HTTP protocol. So it will request information. So it is the interface between the application and the underlying network layer. Okay, so that's the purpose of the application. This is how you are dealing with your network. You don't communicate with the router directly. Do you communicate with the router? You go through the application. Okay. Examples of protocols in the application are SMTP, Simple Message Transfer Protocol for email. Also Post Office Protocol for email. And the Internet Message Access Protocol, IMAP, for emailing. The HTTP for internet browsing. File Transfer Protocol, FTP, for transferring files. Okay? HTTPS. Yes, very good. HTTPS also is similar. It is with security, with secured browsing. Applications don't reside on the application layer of the OSI model. In reality, they sit above the OSI model. In reality. But for understanding, for standard, we consider application part of the OSI. The layer 6 presentation, it has three primary functions. The format, or presenting the data at the source, okay, into a compatible format for the receiver, for compressing and decompressing, encrypting and decrypting. This is all done in the presentation layer. You see how is the encryption done? This, if someone accesses this, they can understand. But then if they see this thing, this is encrypted. The session layer, very important layer, it creates and maintains dialogues between source and destination. This is the secret word, dialogue, always done by session layer. Don't forget that. Dialogue in the question means this is a session layer function. It handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time, and to close the session at the end. Okay, it will also close the session at the end. Okay, it will not be open forever. Okay. Transport layer. The transport layer is responsible for the delivery of a message from one process to another. A process in application message program running on a host. The transport layer deals with process. What is a process? A process is an application/message program running on a host. Yani, I have browser running on my computer. Each application, they have its own port. For the browser HTTP, which port is used? Who knows? 80. So the transport layer knows that this is application and it is using port 80. We call this a process. And it's using TCP or IP, whatever protocol is there. So the two main protocols on transport layer are TCP and UDP, and we will talk about each one. If the message is too large, it is divided into smaller messages called segments. That's why it's called segments. It's divided into smaller parts. Yes. If it's too big, it's divided into segments. Okay, this is how your TCP segment looks like. You have your data and then you have some information at the header. The transport layer, there are many applications or processes running on each host. This is what I have just explained to you. Okay, each process is assigned a port number unique in that host. The transport layer uses ports to identify the application or process. That's why when you send information from your email and you receive reply, the reply is coming to your email, not to your Word or Excel. So how does the computer do that? Because it has port for every process. Okay? When you are on the browser, you type, let's say, cisco.com. You are requesting information from Cisco. The information is coming back where? From Cisco where? To your browser. It will not go to your printer or email. How is this controlled? By transport layer. Yeah. Yes. Okay. So process to process delivery, we call it. As you can see here, each application, it has a port, and the process to process delivery is, so it's coming to the router. The router will route it, okay? And then it will send it to the right application. Email is gone to email, all right? Network layer, the network layer is responsible for the delivery of individual packets from the source host to the destination host, okay? This is the network. Network deals with what? IP address. Network deals with IP address. It can tell where is this sending to. I send it to which router. Okay, I received information. Let's say this information is going to the Cisco router. The Cisco router is the main web server is maybe in London, for example. So it will forward it to router to router to router until it reaches the headquarters, for example. So this is the network layer packet. It has the source IP address, destination IP address, and some other fields and the data. Routing is done by the network layer. It will decide, the router will decide which path it should take, which path your packet should take in order to arrive to the destination. Yes, there are many rules. There are many rules or many guidelines for that. Okay. The IP address or the router depends on the IP addresses. So what is an IP address? IP address is a unique address that identifies a device on the internet or at a local network. IP stands for Internet Protocol, which is the set of rules governing the format of data sent via the internet or local network. We all agree bit is either 0 or 1. Okay? This is the smallest unit for binary numbers or binary system. Then we have a byte. It is 8 bits. If parity is used, then it is 7 bits. But usually it is 8 bits. For the rest of this chapter, we always assume byte is 8 bits. Okay? We have octet. Octet is made up of 8 bits. Is just an ordinary 8-bit binary number. We call it, so each 8 bits, we call them octet. There is hextet, each 16-bit. Okay. IP address, version 4, consists of 32 bits. IP address version 6, 128 bits. They are divided into 4 sections, referred to as octet. Each octet is 8 bits. So 8 times 4, 32 bits. You can depict an IP address using one of the three methods. You can write it, you can describe it like this. You can write it 172.16.3, or you can write it in binary. Okay. And we use the dot. By the way, the highest decimal number of any octet, if you have all ones, it will be 255. If you have all one of 8 bits, it is 255. So you cannot have an octet number, you cannot have an IP address of 205.165.321.1. Why? Because this 321 is invalid. This is valid, this is invalid because it's 261. This is invalid to 645. This is invalid because it's 2. This is valid, by the way. This is valid. Source to destination delivery. So you have your source IP address. It is sending the packet through the router because the destination IP address is here. So the router will be sending all the way to this destination. The data link layer, which is layer number 2, it is responsible for moving frames from one hop to the next hop based on the physical address or MAC address or NIC address. It's the same. The physical address, it is in the header of the data link layer, and it includes source and destination MAC address, as you can see here. In the header, we have source and destination. The MAC address or physical address, it has 48 bits, or they call it the data link layer MAC or media access control address is 48 bits. These 48 bits, they are written as hexadecimal numbers. And we put columns between them. We also call it physical address. And they are embedded on every NIC card. They don't change. They are embedded, burned into the network card. We will show you some network cards, inshallah. So you cannot change it. The traditional MAC address contains two parts. The first part is called the OUI. It's Organizational Unique Identifier or Manufacturer ID. This is half of it, 24 bits. The last 24 bits, they are called the Extension Identifier or Device ID or the card ID. Okay? And manufacturers assign each NIC a unique device ID. Switches, they use MAC address. Routers, they use IP address. So how does the data link layer forward the frames? Data link layer does, so data link layer deals with physical address. Another characteristics of data link layer, it does forwarding for the frames. So the frames that are sent on a LAN are always coming from a MAC address and sent to another MAC address in the LAN. So you see here my switch. This is a local area network here. This frame is coming from computer C. The source MAC address is C. The destination is what? Can you see it? It's B. So the switch will connect. No, switch knows that P is connected to this port. Let's say port 3 or 4. So straight away it will forward it to port 4. It will not go through the router. Directly through the switch. The switch knows I have all the computers connected to ports. So you are coming from C, you are going to B. I know computer B is connected to port number 4. Forward it. All right? The router will do hub-to-hub delivery. Hub-to-hub meaning router to router. because it's traveling throughout your network. All right? Yeah. All right. So here we have end system. It's doing hub to hub. From router to router is called one hub. So from A to F, how many hubs in the middle? Physical layer, last one. Physical layer is the one connected to the cable or to the media. It's responsible for sending bits via a wired or wireless transmission. These bits can be transmitted as wavelengths in the air for wireless, or if it's copper wire, it is voltage, high or low, or light if it's traveling in the fiber optic, maybe light or laser in the fiber optic. Okay, this is how it look like. Last slide. By the way, example for microwave. Sorry, microwave is a wireless signal. Don't forget that. Microwave uses wireless signals. Microwave, there is not the microwave in the kitchen. There is microwave for communication. Yeah. Some buildings you will see some antenna on top. It is directed to another dish on another building. This is microwave connection. Okay. Summary of how the layers work together. So we have application 7 up to 1. The data is going down, and frame, it has header and trailer. Packet has only header. Segment has only header. Okay. I'll show you a video and we will answer. So we'll do a Kahoot exercise also.